Recording in progress.
Okay, we are going to be looking at the states of matter. In our schools, I get some of you got to the states of matter, and we are going to continue with them, though others didn't reach states of matter and you are still doing measurements. It's also going to be a good lesson for you since you'll be learning something new. Okay. So by this lesson, by the end of the lesson, we are going to know what particle theory of matter is and how it explains the properties of solids, liquids, and gases, and how that particle theory also explains the change of state. And then we understand what is the meaning of plasma in physics. So we prepare our books to note down some things, and we also be ready to do some activities. I want someone to read for us what you see on screen. Anyone to read for us? You raise your hand up, 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 and then you read for us. Anyone to read for us what you see on screen? May I see your hands up? Yes, praise. Praise, you read for us. Praise. Let me share again such that we can read properly. I'm sharing a document and I want you to read what you are seeing on it. Yes, who is reading for us? Your voices cannot be heard because you can't. Yes, Daniel. I'm going to ask you to unmute, then you unmute your microphone and then you read.
Yes,
Daniel?
teacher.
Okay, continue.
What do we understand by kinetic theory of matter? The kinetic theory of matter states that matter is made up of very many tiny particles that are constantly moving or that are in a continuous random motion. The degree of movement depends on the amount of energy they possess and their relationship to other particles.
Okay, you have read that the kinetic theory of matter states that matter is made up of tiny particles that are constantly moving and are in continuous random motion. And you have read it that the degree of movement depends on the amount of energy they possess and their relation to other particles. So you can note that down or you can screenshot because it's going to help us explain a lot of things that you are going to find later on in our lesson. You can't unmute yourself, please. If you want to speak something, you raise up your hand. I will do something here and you will be able to unmute yourself and talk. So if you want to say anything, you either write it in the chat or you raise up your hand. I pick you up and then we can be communicating easily. They have read for us that matter is made up of small particles that are constantly moving and they are in continuous random motion. And the degree of movement depends on the amount of energy and they possess and their relation to other particles. Someone is asking me about this being in chemistry. Yes, it is in chemistry, but we also do it in physics because we need it a lot to explain a lot of physics stuff there. Okay. So we have stated our kinetic theory, and now we are going to do the activity that you see. They have told us in the activity that we study the states of matter below and explain their properties in terms of shape, volume, and mass according to the kinetic theory of matter. We are going to study the states of matter that I'm going to show you, and then we explain their properties in terms of shape, in terms of volume, and in terms of matter, according to the kinetic theory of matter, or the particle theory of matter that we are talking about here. So if we have a solid, anyone who can read for us what we have for a solid? Yes, Komagum.
Solids. molecules of solids have very strong forces of attraction. Hence, solids have a definite shape, volume, and mass, are incompressible.
Daniel, thank you for reading for us. But we are going to go through each of those characteristics one by one. Please, after reading, you mute yourself so that we can easily communicate. Thank you. All right, we are going to we are going to have we are going to go through our characteristics that you have seen one by one as they have been shown on the screen. The first one was that the molecules have strong forces of attraction between them. Now, if they say the molecules have strong forces of attraction, there is something that we have to note. So I'm going to change something here so that we can share a white screen, and then we discuss about a solid alone. Now, they have told us that a solid, they have told us that a solid, this is our solid, the particles of a solid are close to each other. So they are joined close to each other, like the ones I'm drawing there on the screen. Let me make my so if that box represents our solid, the particles of our solid are close to each other. Now, being close to each other means that the force of attraction between them is strong. you realize that the forces of attraction between the particles are strong because those particles are packed together. And being that the particles are packed together, they will take on the shape which is definite. Definite shape means that the shapes can be defined. You can tell that this is a square, this is a triangle, this is a kite, this is a circle, because solids always take on a definite shape. And they can also be irregular. Definite shape means that the shape is can be defined. You can say it's an irregular shape if you can't tell if it's a square or a circle or a rectangle. But one thing you have to know that for them, they can't be compressed. The volume of a solid and its mass cannot be compressed because of the strong forces of attraction. Remember, they said that the states of matter, each matter has tiny particles that are moving around. Now you see that the particles of a solid have little space to move around. Therefore, for them, they just do what we call vibration. For them, they will just do what we call vibration. So they just vibrate about their positions because they are close together, and the forces of attraction between them are strong. So that is what we see about a solid. Then we go to another state of matter. So we had those ones that solids have definite shape, volume, and mass, and they are incompressible. Incompressible means you can't compress them easily. That's what we have there. So that is for solid. Then we go to another state, which is a liquid. Anyone to read for us what a liquid is all about? Who is reading for us about a liquid? Any hand? Yes, Cafero.
Molecules of liquids. They have weak intermolecular forces compared to those of solids. Hence, they have a definite mass and volume, but take up the shape of the container in which they are placed. Molecules of liquids are incompressible.
Okay, thank you. Molecules of liquids, the first thing is that they have weak intermolecular forces. The word intermolecular forces means the forces between molecules, or the forces between the tiny particles. They told us, as we stated, the kinetic theory of matter. So those liquids have weaker intermolecular forces compared to those ones in solid. Remember, the solids were close together and they were strong intermolecular forces. Now this one changes a bit because now for them, they have somehow weaker intermolecular forces compared to the solids. So if I'm to try something here, So a liquid will have, this is our shape of a liquid maybe. And now the particles of the liquid are not as close as those ones in the solid. So the liquids will have some particles that look somehow like those ones. They are not far apart, and they are not too close to each other. So a liquid, the molecular forces, the forces between two molecules that are near each other are weaker compared to the solid. That's why they are saying that yes, the liquids have a definite shape and, a definite mass and volume, but for them, they don't have a definite shape. They always take up the shape of the container. That's what they are telling us. They take up the shape of the container. Someone was asking something, but I think people in the chat have answered you well. Asking if both liquids and solids are incompressible. It's a yes. You can't compress liquids. So that is all about a liquid, and then we can move on to, we can move on to a gas. Now, if you look at a gas, they are telling me that gases have very weak forces of attraction, making it easy for the atoms to move freely. And then they continue to say that a gas has no definite volume, it has no shape, and it only has a mass. So there is no volume for gas, there is no shape for gas, but gas can have mass because it is a state of matter, it has a weight. And therefore, you'll find out that these gases, for them, they are compressible. They can be compressed. That's why we say they have no definite volume and no definite shape, because they can be compressed. That is, those are the characteristics of each of those states of matter: liquids, solids, and gases, as we have seen them. Now, there is a state of matter that many of us don't know, and it's called plasma. Some books write it as very hot gases are called plasma. If the gases are very, very hot, then we call it plasma. Or if a gas is ionized. Ionized means that a gas has been separated into what we call ions in chemistry. So they are telling us that if you find plasma, that if you find anyone and that person asks you about plasma, you can say that plasma are very hot gases, or they are ionized gases. The other thing is that plasma are very good conductors of electricity, and they are affected by magnetic fields, And like gases, they have no definite shape, and they also have no definite volume. The difference between plasma and the gas is the temperature that we measure. Gases are temperatures which are measurable, but the plasma has very, very hot temperatures, and we can't be near it. Plasma is common around the sun and in lightning. So if you can measure the temperature of the lightning, then that is when you can get the temperature of plasma. Someone is asking, how is plasma affected by magnetic field? Now, when they say something can be ionized or something is ionized, that means it is separated into positive and negative ions. Now, if something is separated into positive and negative ions, that means that when it enters a magnetic field or an electric field, remember a magnetic field has a north and a south. So if the gas is positively charged, if the plasma is having a positive charge, it will be deflected. Deflected means that its direction is changed towards the south pole of the magnetic field. That is the effect of magnetic field on plasma. For that person who has asked that, how can fire be affected by magnetic field? So long as it is very hot, then it becomes ionized. It makes the gases around it ionized, and those gases, if they pass through the magnetic field, they are deflected, or their directions are changed. So I want you to read that scenario there, and then you will help me write what you think as a person in the chat. I'm giving you 5 good minutes to read through, and then you share with me in the chat. You read through what you are seeing on board, on your screens. Then you give me your ideas in the chat. I'm going to be reading the chat one by one. Thank you. We have 5 minutes to do it. Eh? Okay, we are going to go through the charts and we see what each of you has as the answer. They told us that there is a boy. The boy had for a long time made observations below and needed some explanations from his older sister. First of all, why water is put in a freezer changes to ice, and why hot tea always had smoke coming out of it. So can you help the sister to explain the observation to her brother? And how does kinetic theory explain this? So I'm going to be reading people's answers and I find out what they have. Okay, Senoga Austin tells us that the temperature in the freezer decreases the moment the water particles, making them to become closely packed, or it decreases its movement. Then hot tea, due to diffusion, the smoke particles collide with the hot water particles. Really? No. Then Alexi B says, the temperature in the freezer decreases the movement of the water particles, making them to become closely packed. Thorne says, low temperature in the freezer causes the particles of water to contract and increases the force of attraction between them, hence forming a solid. Gabrin says, because the more you freeze the water, it changes to ice. Ezra says, sir, according to me, I think it is due to the cool temperature in the freezer. On freezing, the kinetic energy of water particles decreases and the interparticle attraction between water particles increases, leading to ice. The other person has said that the temperature inside the freezer is below. It has ended there. So that is what many of you have in the chat. And according to what we have, your answers are close to the correct thing. Now, water in the freezer and the smoke coming out of hot tea is what we are going to be looking at in the change of state. So our new heading should be change of state. All right. If you look at our screen, they are talking about the change of state. Change of state means that we are moving from one state of matter to another. And for this specific lesson, we are looking at 3 states of matter: solid, gas, and the liquid. So they are telling us that when the temperature of a substance is increased, the motion of particles increases. In other words, the speed at which the particles are moving increases. So when you increase the temperature, the speed of motion of the particles increases. And when it increases, the particles become more energetic. They gain more energy and therefore acquire more kinetic energy. So someone can ask me what kinetic energy means. Kinetic energy is energy that is possessed by a body in motion or a body that is moving. So when the temperature of the substance is increased, the speed at which the particles are moving also increases. Therefore, the particles become more energetic and they acquire more kinetic energy. Whereas if there is cooling, or when the temperature is reduced, the motion of the particles decreases and therefore the energy also reduces. So this one will help us explain, first of all, why did we have water put in the freezer and then it became ice? Because the temperature in the freezer reduced the temperature of the liquid. The particles of the liquid lost their energy. And when they lose their energy, they become closely packed, and therefore they become solids, which is the ice. So we are going to see in our states of matter, there is that diagram there where we have solid, liquid, and gas. Now, if you look at that diagram, when we have a solid and that solid turns into a liquid, we call that liquefying or melting. If you look at that, solid to liquid is melting, then liquid to gas is evaporation. The smoke that comes out of a liquid as it burns is called evaporation. Then if we come back from gas to liquid, that is condensing or condensation. And from liquid to solid, we call it freezing or solidifying. So you can draw that one and you put all those things that happen to the states of matter, such that when someone asks you about any of them, you can be able to tell. The last one is sublimation, from solid straight to gas. It's called sublimation. or subliming. So you draw that diagram and then we see how to continue. All right, we have finished drawing, and then we are looking at one by one process. If someone talks about melting, what does it take for melting to happen? Anyone to read for us what you see on screen? Anyone ready? Yes, Calvin.
Melting or liquefying. When a solid is heated, the particles gain energy and start to vibrate faster and faster, overcoming the attractions between the particles and allowing them to pull them apart. The temperature at which a substance changes state from solid to liquid is called its melting point.
Come again. Okay. Calvin has read for us that when a solid is heated, the particles gain energy and start to vibrate faster and faster. So as they vibrate, they overcome the attraction between the particles, and therefore this allows them to pull apart. Now, when they pull apart, it means that they are not now closely packed as they were as solids. So that means that the temperature at which a substance changes, or the temperature at which the particle is now allowed to pull apart from solid to a liquid, is called the melting point. So if someone asks you what causes melting, you say that when temperature increases, the particles in the solid gain energy and they start to vibrate. The vibrations are enough for the particles to overcome the forces of attraction between them, and therefore they pull apart, which means that the solids now become liquids, and at that temperature called the melting point. Then boiling, anyone who to read for us about boiling? Yes, Derek?
Church Daniel.
Yeah, sorry, Daniel. As you read slowly so that we can follow up.
Okay. If a liquid is heated, the particles are given more energy and move faster and faster, expanding the liquid. And as the liquid gets warmer, more particles have sufficient energy to escape from the liquid. Eventually, even particles in the middle of the liquid form bubbles of gas in the liquid. At this point, the liquid is boiling and turning to gas. And lastly, the temperature at which this happens is called the boiling point or boiling temperature.
Okay, thank you. They are telling us that boiling liquids, when the liquids are heated, their particles are given more energy because we learned that temperature increases energy of the particles. So they move faster, and therefore, as they move faster, the liquid expands. So as the liquid expands and gets more warm, particles start to move out of the liquid, which they call escaping. So they escape out of the liquid, and as they escape out of liquid, they escape as a gas. So they are telling us that eventually particles in the middle of the liquid form bubbles of gas in the liquid, and at this point, the liquid is boiling and turning to a gas. The temperature where this happens is called the boiling point. And after this boiling, I think that is when we go to evaporation. So who is reading us about evaporation? Anyone to help us to read about evaporation? You raise up your hand. Take F1. Next time you rename your device so that we can call you by name, not by device. Okay, read for us.
Within a liquid, some particles have more energy than these more energetic particles may have sufficient energy to escape from the surface of the liquid as gas or vapor. This process is called evaporation. It takes place at room temperature, which is often well below the boiling point of the liquid. As the temperature increases, the rate of evaporation increases. It happens from the surface of the liquid. It is assisted by wind conditions, which help to remove the vapor particles from the liquid so that more escape.
Okay. Thank you for reading for us.
Welcome.
So they are telling us that evaporation, first of all, it's the most energetic particles that escape from the surface of the liquid. And they become vapor, or they become what they call a gas. So that process is called evaporation. And it takes place from any temperature, which is from room temperature and above. So as the temperature increases, even the rate of evaporation increases. That means the more the temperature, the more particles that escape from the liquid to form gas. And they also told us that this evaporation takes place at the surface of the liquid. And it can also be assisted by windy conditions, which help to remove the vapor particles from the liquid so that more can escape. So whenever particles come to the surface, the wind blows them away, then they leave room for other particles to come and also escape from the liquid. Someone is asking what a room temperature means. Now, someone asking me about room temperature. Any temperature that is 25 to around 28 is called room temperature. So if you are asking how hot room temperature is, I think you have got the answer to that. Excuse me. Okay, we continue to condensation. Who is reading for us about condensation? Yes, Rhoda.
As the gas particles cool down and lose energy, they will condense or liquefy and turn back to liquid. In fact, the steam coming out of a boiling kettle can also be seen because some of the gas particles have condensed to form small droplets of water.
Okay, so Rhoda has read for us that condensation is particles cooling, gas particles cool down to become liquids again. So if you know, if you have ever had the kettle and you remove the cover of the kettle, you realize that there are some water particles under that cover because they are particles of gas or of smoke that wanted to go out, but then because they couldn't go out, their temperature reduced from there and then they became liquids back. So condensation can be also called liquefaction. Then freezing, we have it as that liquid particles cool down and lose more energy, and then they will solidify and freeze back to solids. So what causes the ice is because liquid particles are losing their energy, and then they are becoming more close together, and therefore they will make what we call a solid. Lastly, I think it's sublimation. Now, sublimation is where we have direct switch from solid to gas or from gas to solid. So that is what we call sublimation. So in case any person asks you of the energy of the states of matter changes, or the change of state in matter, then you can explain and tell that person about freezing, sublimation, condensation, evaporation, melting, and each of them has a definition, and you can explain it according to the kinetic theory of matter. So we have that activity there. I want you to copy the questions. I give you 10 minutes You go through each of them and you write an answer for each of them. There is echo in my background. Where is the echo coming from? Okay, sorry about the echo. There are 3 explanation questions that we are going to look at. And we are going to write our answers in the chat one by one. So you look at the question, you see how it relates with what we have seen, and then you write your answer. You have 10 minutes to do that, and then we discuss the rest of the things that are coming up. Okay. Thank you for the answers I'm seeing here. I'm going to go through them one by one. And as I go through them, I would like you to copy these questions for our homework today. Copy them down. So you note number 4 is how can you make ice cream, not S. The S on the cream, you remove it as you copy. After we have copied our after you have copied this homework, I want you to go and research on one by one, such that in our next lesson, we can have the answers about each of them. So for today, I want us to recap on what we have seen. We have talked about the kinetic theory of matter, where we said that states that matter has small particles which are moving in constantly, but in random movements. And we saw each state of matter and how it applies to the kinetic theory. And then we also looked at the changes of state from one state of matter to another and how each of them happens. So our homework is about the applications for the states of matter. Each one you are going to be writing about its application, and we'll be getting that work, I think, in our next lesson. Someone is requesting I put back the kinetic theory of matter. It was on our first. So you can copy it as it appears on your screen.